about the quadratic discriminant. It's going to be quite a long question, so you may want to pause and reflect at certain times. Now let's have a read of the question. We've got a line and a curve that do not intersect. Now here's the key words, the trigger words if you like, do not intersect. That means that if I make them equal, there are no solutions. So I'm going to take 2x squared plus 3x, this is a plus 3 in here, equal to kx plus 1. They don't intersect. There are no solutions. What I'm going to do first of all is I'm going to rearrange it to make it equal to 0. So 2x squared, this is plus 3x, and I'm going to take kx away, so it ends up being plus 3 take away k x's. I'm going to take away this 1 from both sides to make it plus 2. And now it's equal to 0. So now I've got a quadratic. I've just got one k, I've got k in there. The quadratic has no solutions. Now previously, we've done some questions, but the first thing we should have learnt was this. B squared minus 4ac is less than 0 if there's no solutions. So we actually know there's no solutions because they don't intersect. So I know that I could start off with b squared minus 4ac is less than 0. Now my b squared is 3 minus k squared. Minus 4 times 2, which is 8, times another 2, which is 16, is less than 0. So this is going to give me 9 minus 6k plus k squared minus 16 is less than 0. Let's rearrange that. K squared minus 6k, 9, take away 16, is going to give me minus 7 is less than 0. Now, this is fine, but what I would like to do is actually solve it to be equal to 0. So it's like a little bit of working out here that I'm going to do. I'm actually going to do k squared minus 6k minus 7 is equal to 0. And I just put it in blue because it's not actually what I'm working out. But when I factorize that, I get k minus 7 and k plus 1. And these are like the two values of k equals 7 and minus 1, that we're going to lie either between or outside. Now in the last video, if you watch the last video, I did a number line here and I put critical values on the number line. So onto this number line I put 7 and I put minus 1. And I tried out different regions. So I'm going to try and make k bigger than 7. Okay, these numbers here from the solutions. So I'm going to make k 8. And let's go to one of the inequalities, perhaps this one. And I'm going to make k 8. And I'm going to see if it will work in this inequality. So 3 minus 8 is minus 5. I square it to get 25. I take away 16 and I get 9. 9 is not less than 0, so this region doesn't work. I'm going to choose a number between here and here. The obvious one is 0. 3 minus 0. 3 squared is 9. 9 take away 16 gives me a negative number, and it's less than 0, so this one works. And here another number, and I'm going to choose something like minus 2. So 3 minus 2 is going to give me 5. I square 5, I take away 9, 16, and I get 9. And 9 is not less than 0. So having made it equal to 0, having looked for the answers, the solutions by factorizing or using your calculator, I use this number line and I'm able to work out the values that I want k to be. So I want k to be less than 7. I want k to be greater than negative 1. And for these solutions, the lines will not intersect because that's where they're less than 0 and this is satisfied. It's quite a long question. despite being on one of the first topics, it's the sort of question you might get on a paper 1 towards the end of the first section.